Almost every piece of technology keeping you alive right now shouldn't exist. They weren't carefully calculated by flawless geniuses working in pristine, sterile laboratories. No, they were the direct result of terrifying mistakes, ruined experiments, lazy afternoons, and violent explosions that should have killed the very people who caused them. We are taught that progress is a straight line, a rigid ladder of logic and math. But the truth is far messier. Humanity has a habit of stumbling into the future completely by accident. We conquer the forces of nature not because we are perfectly prepared, but because we are incredibly clumsy. And sometimes dropping the wrong thing at the wrong time changes everything. The year is 1903. Inside a dimly lit French workshop, a chemist is reaching for a glass flask on a high shelf. His sleeve catches the rim. The glass slips. It falls through 15 feet of empty air, plummeting toward the hard, unyielding wood floor below. In any ordinary universe, this story ends with a loud crash, a pile of sharp debris, and a ruined afternoon. But when the flask hits the ground, the sound is muffled. The chemist looks down, bracing for the mess, but instead he sees a miracle. The glass is shattered. Yes, it is covered in a dense, intricate spider web of 1,000 fractures. But it hasn't been pieced apart. It is still whole. It is still standing. The flask has refused to break. He examines the ruined container under a harsh studio light. The flask wasn't empty. Weeks prior, it had contained a liquid plastic mixture, collodion, that had completely evaporated, leaving behind an invisible microscopic film coated perfectly along the interior walls. The liquid was forgotten, but the transparent shield remained. It held the dying, gasping shards of glass together in a permanent, unbreakable grip. At that exact moment in history, the first early automobiles were hitting the roads. Their windshields were made of ordinary glass. When a crash occurred, that glass became a flying cloud of lethal, razor-sharp daggers. The dropped flask changed all of it. By mimicking a lazy mistake, we learned to sandwich that invisible layer of plastic between sheets of glass, creating safety glass. A simple, clumsy slip of the hand that has saved millions of lives from bleeding out on the asphalt. 35 years after a dropped flask reshaped human safety, another accident was quietly waiting to rewrite the modern world. This time, inside a high-pressure chemical laboratory in New Jersey. The year is 1938. A young researcher is attempting to engineer a new, non-toxic gas for refrigeration. He fills a heavy steel cylinder with a highly volatile chemical compound, freezes it in dry ice, and locks the valve tight. He expects a predictable mathematical reaction. But science rarely obeys expectations. The next morning, the researcher returns to his bench. He attaches a pressure gauge to the heavy cylinder and cranks the metal valve wide open. Nothing happens. No rushing hiss of escaping gas. No drop in pressure. Nothing. According to the weight of the steel tank, the volatile compound is still sealed inside, but the gas itself has completely vanished. Frustrated and operating with a level of recklessness that would be completely forbidden in a modern facility, the researcher makes a radical decision. He takes the heavy iron cylinder down to a dark machine shop, locks it into a vise, and begins to saw the pressurized metal container completely in half. Each stroke of the saw sends bright orange sparks cascading across the concrete floor. Every second should end in an explosion, yet the cylinder remains silent. The blade cuts through. The cylinder splits open. But there is no explosion and no burst of gas. Instead, the researcher looks inside and finds a miracle born of pure error. The interior walls are no longer bare iron. They are coated in a strange, chemically altered, snow-white powder. The frozen gas hadn't leaked. It had spontaneously polymerized, bonding into an entirely new solid matter that shouldn't exist in nature. He scrapes a small sample of the white powder onto his workbench. It is impossibly smooth. In fact, it is the slickest solid material known to mankind. Virtually immune to friction, completely waterproof and utterly impervious to the most corrosive acids on Earth. Today, the world knows this strange white material by another name: Teflon. A substance so chemically inert that it was immediately classified as a military secret, used to seal the hyper-corrosive uranium gases needed to build the first atomic bombs, before eventually finding its way into your kitchen. Two massive, world-altering breakthroughs, both born from human clumsiness and a total failure of expected physics. But while some accidents hand us the physical materials to reshape our world, others tear open a veil to the completely invisible. To find our next accident, we must step back even further into the dark, into a pitch-black room where a rogue current of electricity was about to expose the terrifying secrets hidden beneath our very skin. The year is 1895. Long before dropped flasks and frozen gases changed our world, physics was operating in the dark. Literally. Inside a pitch-black university laboratory, a lone researcher is investigating the behavior of high-voltage electricity. He passes a powerful electrical current through a vacuum tube made of thick, heavy glass. To ensure no light escapes, he has wrapped the tube entirely in black cardboard. The room is entirely devoid of light. The researcher flips the high-voltage switch. The machine hums to life in the shadows. He looks toward the covered glass tube, expecting absolute darkness. But out of the corner of his eye, several feet away from the workbench, he notices a faint, ghostly shimmer. A piece of cardboard coated in a chemical salt is glowing with an eerie, pale green light. This shouldn't be happening. The cathode tube is completely sealed in thick, black paper. Light cannot escape it. Yet, whatever invisible force is leaving the tube is passing effortlessly through the cardboard, traveling across several feet of empty air and striking the chemical screen. The researcher places a thick book in front of the tube to block it. The screen keeps glowing. He places a sheet of wood. The invisible wave passes through it like a ghost. Driven by a mix of profound scientific curiosity and pure dread, the researcher takes the ultimate risk. He raises his own hand and places it directly into the invisible path of the unknown radiation, right in front of the glowing chemical screen. He looks up at the cardboard. What he sees makes his blood run cold. It is a silhouette, but not of his hand. It is a stark, high-contrast shadow of his own bare bones. He was looking directly at his own skeleton while he was still alive. Because he didn't know what these bizarre invisible waves were, he simply logged them under the mathematical symbol for the unknown. He called them X-rays. A total accident of a poorly covered high-voltage tube had suddenly torn open a veil to the unseen architecture of the human body. Within months, battlefield doctors were using this clumsy mistake to locate bullets deep inside wounded soldiers, changing medical diagnosis forever. Electricity, glass, and volatile chemicals, all tamed and exposed through our own brilliant errors. But while peering through the human body changed how we see death, our next great blunder would change how we fight it. To find it, we must fast forward 33 years into a famously messy laboratory where a single window left open over a damp weekend was about to save hundreds of millions of lives from a completely microscopic enemy. It is September 1928. Inside a cluttered, famously untidy laboratory in London, an unnamed bacteriologist is preparing for a 2-week summer vacation. He's been studying Staphylococcus, a deadly, highly contagious bacteria. Instead of cleaning his workbench, he simply shuffles his live, active petri dishes into a messy pile on a corner and locks the laboratory door. The room is left empty, but it is not secure. A single window, forgotten over that humid London weekend, is cracked open. A rogue draft moves through the dark workspace. Somewhere, likely in a moldy apartment nearby, a tiny ancient life form releases its reproductive spawn. A single unseen spore of a rare mold drifts through the open laboratory window and settles precisely into one of the researchers' forgotten open petri dishes. Then, a freak environmental variable occurs. The London weather shifts. A sudden cold snap hits the city, plunging the temperature in the laboratory far below normal. The aggressive, heat-loving bacteria colonies go dormant, stopped cold by the physics of the room. But the invasive mold thrives in the damp chill. It begins to creep across the agar, breeding undisturbed, slowly consuming the battlefield while the enemy is asleep. The researcher returns from his vacation. He sits at his bench and begins sorting through his ruined, contaminated experiments to throw them away. He pauses, holding one dish under his clinical bench lamp. It is contaminated. Yes, covered in a large patch of fuzzy green-blue mold. But right around that mold patch, there is a pristine, glassy ring of complete destruction. The bacteria haven't just been blocked, they have been dissolved, ruptured, vaporized. He realizes that the mold is fighting for territory. To survive against the massive bacteria colony, it is secreting a self-defense chemical that forces the enemy's cell walls to burst. The forgotten window, the messy desk, the lucky cold spell. A cascade of simple human clumsiness and random weather physics had combined to hand us the ultimate weapon against infectious disease. We had accidentally discovered penicillin, ending millions of years of human powerlessness against the microscopic world. Dropped glass, jammed valves, rogue electric currents, a messy desk. We stumble into the light only by failing. But while most of these errors altered how we fight death or navigate the physical world, our final, most explosive accident didn't come from a university laboratory at all. To find our last paradox, we must look at a massive military-industrial machine built to win a war, and how it was defeated by a single piece of melting confectionery. The final paradox of human error moves us away from university laboratories and into the shadow of the Second World War. The year is 1945. A massive industrial military complex is operating with absolute precision to build a revolutionary defense system, the cavity magnetron. This powerful vacuum tube was designed to generate high-energy radio waves, enabling radar technology to track enemy aircraft through pitch-black skies. A massive industrial researcher, a true giant in early electronics, is standing next to a live, active magnetron tube, analyzing its behavior. The machine is radiating pure, focused electrical energy. The researcher does not feel the radiation. He does not feel any heat on his skin. He assumes the space between him and the live machine is an empty void, but inside his trousers, the molecules of the universe are already in a violent panic. He pauses his work, reaching into his pocket for a standard solid chocolate bar he had saved for later. His hand finds only a hot, viscous, formless soup. Confused and operating outside the parameters of his primary experiment, he grabs a packet of raw popcorn kernels and holds them right in front of the active magnetron cavity. They immediately erupt in slow motion, popping with violent force, triggered not by fire, but by invisible electricity. He realizes that the focused radio waves aren't just for detection. By absolute accident, he has discovered that certain frequencies, precisely matched to the resonant frequency of water molecules, can force that water to vibrate rapidly, generating immense friction, and therefore heat. The ultimate industrial military machine, built to detect death from the sky, was suddenly defeated by a single piece of melting confectionery. He had just accidentally invented the microwave. By applying military failure to human hunger, we tames the energy of stars into a simple plastic box in your kitchen. This is the ultimate symmetrical lesson, a massive, war-winning invention, derived only from a moment of profound scientific clumsy. Dropped flasks, jams, rogue currents, messy desks, and melting chocolate. Humanity does not master its future through success. We stumble, and our failures are the paradoxical fuel of progress. We are taught that progress is a straight line, but the truth is far messier. Humanity has a habit of stumbling into the future completely by accident. We conquer the forces of nature not because we are perfectly prepared, but because we are incredibly clumsy. And sometimes dropping the wrong thing at the wrong time changes everything. We look back at history and see a grand monument of human design. We praise the blueprints, the formulas, and the flawless architects. But look closer under the clinical light of truth. The modern world wasn't built by a master plan. It was forged in the chaos of human error. Our greatest leaps forward didn't happen because we followed the map, but because we took a wrong turn. So the next time you drop a glass, leave a window open or watch a plan fall to pieces. Pay attention. Perfection keeps us exactly where we are. But failure is the true, unpredictable engine of progress. It is the paradox that keeps the universe moving forward. And sometimes, the absolute best thing humanity can do to change the future is to make another mistake.